We are going to continue with chapter 4 and Kirchhoff's voltage law, better known as KVL. It's a fundamental circuit law. It states that the algebraic sum of all voltages around a single closed path is 0. So this is just one representation where we have B source is equal to B1, B2, B3, to Bn. So we have summation of this voltage, that voltage, that voltage, that voltage, and X or n number of voltages is equals to Bs. Or we can say that the summation across all the loops are equals to 0. The summation of all the voltages across the loop are equals to 0. So we have B1, B2, B3, Bn plus B source is equals to 0. We put positive in front of the voltage drops, but we have to take into account the polarity of the voltage drop. We are going to do this example so you understand what does that mean. In example 4-13, we have a simple circuit. We have the voltage source, we have the voltage drop across this resistor, voltage drop across that resistor. So I'm going to select a point in the loop and I'm going to start doing the KVL, Kirchhoff's voltage law, across this loop. So I'm going to mark here so I know where to start and where to end. So I'm going to start. I have already assigned the positive and negative of this voltage drop, positive and negative of this voltage drop, and then negative and positive to this voltage drop. So we are going to start 5, enter from the positive, so it's positive, then enter from the positive 10, and I continue, enter from the negative B source, and then I continue and I end right where I start. So I have 5, 10 minus Vs is equals to 0. I solve for V source is equals to 15 volts. That's what it means that to go across or do a KVL loop. In example 4-14, it says determine the unknown voltage drop across B3, which is right here. So I pick my point, my start and end point, and I go. Positive, I have assigned the positive, negative polarities for all my voltage sources. So here I have 12 volts, positive 12 volts. I have 25 volts. I have B3, and then I have B source, which is 50. Here I say the voltage drops because these are the voltage that this resistor gets consumes. So I'm not putting the resistor value, but I'm saying B1 is that, B3, B2 is that, B3 is that. That's what I mean, not to be confused that now the resistor value is 12 volts. No, the resistor value we don't know, and we can find it, but we are not interested in that yet. We are interested in the voltage drop across this resistor, which are given to us. So from there, I equate it to 0, and then I solve for B3. So B3 happens to be 13 volts. Right here in -14, I'm going to have the resistor values, and they are asking us to find the voltage drop across each resistor. So I'm going to do it in two different ways. One, I'm going to use Ohm's law, and a different one, I'm going to use KVL. So in order to start this process, I'm going to find the current, which is given to us as 10 milliamps. I'm going to solve for R4. So R total is V total over I total. So it's 5 kilo ohms. I know that R total, it's going to be plus 1, 2, 3, and 4. So R4, if I solve for R4, R4 is going to be R total minus R1 minus R2 minus R3 to be 3.43 kilo ohms. Now I can find the voltage, right? Now I can find the voltages using the KVL. So if I find the voltage using the Ohm's law, I have I times R. The I is 10 all across, and the resistor changes. The V1 for voltage 1 is 100, for voltage 2 is 470, for 3 is 1000, and for 4 I don't know. But I have solved for it over here. All right, so let's see how I did this. So using a KVL, I know that B1, B2, B3, and B4, and B source is equals to 0. So 1, it's 1, 2 is 4.7, 3 is 10, 4 I don't know, source I have it, and my B4, my voltage across B4 is 34.3 volts. So I can put it here. Then from here, I can solve for my R4, which is 3.43 kilo ohms. So if I compare that to what I found using the Ohm's law, I see that they are the same. So there is two different ways you can solve for a unknown quantity. In this case was B4 and R4. Voltage divider. As I mentioned earlier, voltage divider is an important characteristic of series circuits. Series circuits acts as a voltage divider. It is an important application of it. The total voltage drop across a single closed path divides among the series resistors directly proportional to the resistance value. The smaller the resistance has the least voltage. So the smallest resistor has the smallest voltage. So if R goes higher, B goes higher by this relationship, where I know the voltage is equivalent to current times resistance. So for example, here I have a source of 10 volts. I have B1 and B2. This resistor is 100, this other resistor is 200. So since this resistor is twice the value of the resistor number 1, the voltage should be twice the voltage here. So B1 is half the voltage at B2 because R1 is half the value of the resistors as R2. So let's do this numerically so it can make sense for you. So I can find my I total. B total divided by R total, I get 33.33 milliamps. Then my B1 is going to be 100 times my current, so I get 3.3 volts. My B2, I'm saying that it should be double the B1, so I'm going to prove it mathematically, and I get 6.6 volts. So yes, 6.6 is twice of 3.3. So this relationship holds. Voltage divider formula. Voltage divider formula is very, very useful because it saves us time. If we want to solve for a voltage or a specific branch, or in this case a series circuit, then we don't have to find the currents. We define that the voltage across that resistor, it is just a ratio of that resistor compared to the total resistors multiplied by the source. So if I am interested in voltage X, I'm going to divide resistor X by the total resistors and multiply it by the voltage source. Voltage drop across any resistor or combination of resistors in a series circuit is equal to the ratio of the resistance value to the total resistance by the source voltage. In example 4-16, we have R1 to be 82, R2 to be 68, and they're asking us to find B1 and B2 using the voltage divider. So my R total is 150. B1, I can use Ohm's law, I can find the current, and then from the current, I will have to multiply the current times the voltage times the resistor to get the voltage. But using voltage divider, what I do is I take the value of the resistance 1, divide it by the total resistance, multiply it by the source, and I get the value of R1 or B1. And then I do the same for B2. R2 divided by R total multiplied by the source is equivalent to 68 divided by 150 times 10, so I get 4.53 volts. Okay, 418 is a long example, so we are going to stop right here. We are going to leave that for the next video.